Hey class, this video is on shifting exponential functions. So our previous notes or Edpuzzle was on graphing exponential functions. That's where we plugged in values into a table and then we plotted those 5 points on a coordinate grid. So what we focused on was, in this exponential function, we focused on the b value, that was our base, and then to the x exponent. We haven't looked at the other components of this, so really what we're going to do in this video is highlight what does this h value do and what does this k value do. So I'm just going to circle those two things. Now this a value does something, and only real thing that I want you to get out of this video is if the a value is less than 0. What that means is if the a value is negative. All that does is that so then what you do is you reflect all the points. Really what it looks like, it's going to be upside down. So like if you were to have an exponential growth function, if it were negative, then you would have an exponential growth. Or usually it goes flat and then up, but then if you reflect it, it's going to give you this kind of pattern. Okay, we're not really going to go into detail there. So the steps, just to remind you of how to graph an exponential function, is that we plug in the values from -2 to +2. So that's -2, -1, 0, 1, and 2. Into the parent graph, so that's just whatever the base is combined with an x exponent. And then we're going to shift those points, or if we need to, move the asymptote. So this first part, we're going to highlight the k value. This shifts the points, and this shifts really the asymptote. That's that invisible line, straight horizontal line. It's going to shift that up or down. So in here, our k value for this first one is -4. Our b values too, but we're focusing on our k value. Our k value is -4, and what that does is that shifts all the points or the asymptote down 4. So if it's negative, it moves down. If it's positive, it moves up. And the second one is positive. It's +5/10. And since it's positive, it's going to move it up. Not much. So it just moves it up 0.5. Okay. Now for this, I'm just going to go through the table super fast just so we're not taking too much time. When you use the table, you have to use the parent function. So I'm using the base and x exponent. I'm ignoring this -4 for now. So that's why I just have 2 to the x power. If we were to plug in -2 into the x, or any of these values into the exponent, we're going to get an output. I'm going to begin at 0 because 2 to the 0 power is 1. 2 to the first power for 1 is 2. If I were to plug in a 2 in for the exponent, 2 to the second power, 2 times 2 is 4. Okay. And you can do the work for this, but when you plug in a -2 into the exponent of x, this is going to give you 1/4. Right, 2 to the negative power is we don't ever want negative exponents. We have to cross the line, change the sign. And then here, we're going to have +1/2. I'm just going to graph those points. So our first coordinate is -2, 1/4. So that's 2 to the left and the 1/4 up. So just a little bit up. It's a quarter of the way to 1. -1, 1/2. So that's 1 to the left, a half up. So directly in between 0 and 1. 0, 1 is just right here. 1, 2, right there. And then 2, 4. We're going to go 4 up for this. Looks like it's right there. So this exponential is not our final graph. This is just 2 to the x power. All right. Now for our example though, we have, I'm going to highlight this in blue. We have 2 to the x power -4. What does this -4 do? Is that it's going to move everything down 4, right? We actually did that over here. And when we do that, we're moving the asymptote. The asymptote's right over here, right? An asymptote is a boundary line that the graph will never cross. So since that's, I'm going to draw this dashed line here. Can really can't see it because the axis. We're moving that down 4. So I'm going to move it down. So 1, 2, 3, 4. I'm going to redraw that line. All we're doing is just shifting everything from our original graph down 4. So that goes with the asymptote. That also goes with the points here. So this point right over here is a quarter of the way up. So I'm going to count down 4. So if I count down 1, it's going to be a little bit above this line. 2, a little bit above, 3, and then 4. It's just right over here. It's not quite at this boundary line, but just above it. The next one is -1, 1/2. So I'm going to go down 1, 2, 3, 4. All right, so we're directly in between, just like how on our original asymptote it was a halfway above the 0 and 1. Now it's halfway above these 2 points right here. Here we're going to count down 4 again. So 1, 2, 3, 4. And then here, 1, 2, 3, 4. 1, 2, 3, 4. You might need to pause the video in case you can't quite see like where am I actually putting the points at. But let me go ahead and draw this curve. And it's also gonna just kind of grow this way. So if like really what you're thinking about this is this red curve, we're just shifting it down forward. That's pretty much it. All right, class, so in case you didn't believe me, I have this graph over here. This is on the website desmos.com, and you can use the same thing if you need help graphing exponentials. So what I have graphed right over here is 2 to the x power. I plugged in the points, and really I'm just gonna press this button right over here. When I do that, it's just gonna show 2 to the x power minus 4, just so you know. I think a lot of times when I say things, we're like, that's not true, so let's have a computer do it. So if I plug that in, you get this blue function to represent our final function, 2 to the x power minus 4. And really all we're doing is we're just moving it down 4, right? This point right here is going down 4, so this is down 1, 2, 3, and that's how you get this point right here for 4. You're shifting this down 4, this down 4, this down 4, this down 4. What's weird is that it looks like usually students will try to draw like parallel lines or curves where they're kind of equidistant. But this looks like it's going to converge, like going to intersect. It's not. Like they're both increasing and going to the right. It's not really going straight up. Like if I were to continue, like it looks like it's touching, but if I zoom in, they're actually not touching. Okay, right, so we're actually zoomed in a lot. All right, so this was just a little bit of an explanation of like why we have these functions. Okay, we'll get to the next example. All right, class, this is the second part for graphing the h-value. Now, the h-value here is the thing that's in the exponent. It's grouped with the x. Now, there are a bunch of ways I could explain what it does, but I think the simplest way explaining it, we'll go into more detail in class, is all this h-value does, so in this case, it's 3. It shifts it left or right? K-value moves it vertically, this moves it horizontally, but the opposite. And we're going to go into detail why it's the opposite. The thing is, the easy way is just remember it's the opposite. That's it. Okay, left or right, opposite. Now, this plus 3 on the number line, you would think it's right 3. Okay, right 3 on a number line. But since we're saying it's the opposite, it's actually not going to be right 3, but this would actually be shifting it to the left 3. Whatever our function is, we would move it 3 to the left. Okay, right over here before I graph this part, x minus 2. -2 on a number line is 2 to the left. But remember, the opposite, it's not going to be 2 to the left. It's actually going to be 2 to the right. So I'm going to give you the values over here. If we were to plug in -2, -1, 0, 1, and 2 into our exponent, really if I were going to plug in 0 into this, it would be 1. 1 to this would be 1/2. This would be 1/4. Very similar to our first example. And then we'll have 2 and 4. So I'm not going to go really into detail for that. If you want to try to plug it in and simplify it, sure, you'll get those outputs. All right, so just graphing our parent function, 1/2 to the x power. So -2, 4, so that's 2 to the left and 4 up. -1, 2, 0, 1, 1, 1/2, 2, 1/4. So I'm just going to go ahead and graph that as best I can. It's kind of hugging the asymptote. So this is just 1/2 to the x power. The thing is, our original function, right over here, we haven't graphed yet. Okay, so what we're going to do is we're going to shift these points. So where do we shift them? We already identified that's going to be 2 to the right. So I'm going to get every single one of these points. Now, the asymptote does not move. If I were to move this to the right, it still stays that line. So this point, 2 to the right, goes right over here. Its new home is right over here. Okay, this next one, 2 to the right, it's right over here. 2 to the right, estás aquí, right over here. And the last one, move it 2 to the right, somewhere right there. It's just like if you were standing somewhere and I just moved you to the right a little bit. You're still the same thing, you're just shifted. So this final graph is the 1/2 to the x minus 2 power. And that's pretty much it. Just remember it's left and right, it's always the opposite direction. Alright, so let me go and show you on the graph what this looks like. So what we have in orange is 1/2 to the x power. That was our original graph. And just looking right over here, we have 1/2 to the x minus 2 power. I have to put that in parentheses for this to work in the computer. But just looking at this, right? So this is the original function. This, if I press it, it's gonna look like it's moved 2 to the right. Yes, it does. Okay, right? It's just, this was A, now B. A, B. Same exact thing, just 2 to the right. Alright guys, that's been a shifting exponential function video. Let me know if you guys got questions. Bye.